The game structure consists of various scenes that alternate to change panels, levels, or menus, for example. For our game, we need an entry scene with the game's title, a scene for the main menu, the level we have been developing, a scene for the win screen, and another for the lose screen. Also, we will need a credit scene. To make these scenes, we will create a new 2D-based scene. In the 2D node, we add a color rectangle. In the color rectangle inspector, we adjust the layout transform to 9020 by 1080 and change the color to something darker. To the color rect, we add a label for the scene's title. In this case, it will be the name of the game. We place another label at the bottom of the screen and we write "Press Fire to continue." We save the scene as intro and now we have our first scene. The others are quite similar to this one, and for that, save as with another name and change the title. Thus, we do save as and change the name to main menu, win screen, lose screen, and credits. Now that we have the necessary scenes, we should change the title of each one to make it easier to identify which scene we are in. To change scenes in the game, both automatic and through player's intervention, we will have to program various scripts that handle these changes. Let's start with a change from the level to the lose scene. We create a script called Level Manager and place it in a node also with the same name, in the scene Level 1. As we want to see the player's explosion before changing scenes, we will need a wait time after the player dies. We declare a variable for the wait value and another for the counting. To find out if the player is still alive or not, we need to access game data. This is also where we can initialize the level by setting the level score and the counter to 0. In the process function, we check if the player's life has dropped to 0. If so, we start the countdown, and when the wait time is reached, we execute the command that loads the lose screen scene. In Godot, when we run level 1 and wait to die, we can see that after the player explodes, there's a pause, and the lose scene appears. However, there is a problem. It seems that the level 1 scene has not been removed. In the scene panel, we can see all the nodes that make up the scene we are working on, but when we run the game, we end up with two windows, a local one showing the structure in the Godot, and a remote one showing the game Windows structure. In level 1, we rename the root node to level 1, and when we run the game and switch to remote, we see that the game's structure is not quite the same as we have it in Godot. Here we can see level 1, game data, which is an autoload, both as children of root. When the player disappears and the scene changes to lose scene, we can see level 1 disappear, but not all the aliens and lasers. This happens because when we instantiate these elements, we are placing them as child of root, which is indeed happening, but what we want is for the instances to stay as a child of level 1. To solve this problem, we can search for the root, as we already do, and instantiate the elements inside the first child, which will be the level. However, this won't be possible with game data or game events present, or even in larger games that have parts of the levels being added over time. Considering all these issues, the most direct way to access the main node of any scene is for this node to mark its presence as soon as it appears. When level 1 loads, the level 1 node will place itself in a static variable, accessible to all other scripts, and when the instantiators need to point to the parent, they point to the variable. We create a script named main node and add it to the main node of the level 1. In the script, we declare a static variable to reference the main node of the scene, and in ready, we place the node itself in the variable. At this point, any script that refers to main node.currentScene will get a direct reference back to the main node of the scene that is running. To fix the instantiators to make them instantiate in current scene, we go, for example, to player canon, and where we have get3.root, we replace with main node.currentScene. We need to make this change to all instantiators, and one way to not forget any is to choose the option replace in files and put get3.root in the search and main node.currentScene in the replacement. By clicking replace all scripts will be changed. If we run the game now and check the remote tab, we notice that we no longer have aliens, lasers and explosions appearing in root. In fact, all these elements are being instantiated inside level 1. We can also confirm that we no longer have that strange behavior that changed the level but kept the aliens flying. Now, when we change scenes, we are removing level 1 and, consequently, all the elements that are inside it. In all the scenes, we put the main node script on the main node, always ensuring a direct reference to the main node if it is necessary. Now that we have solved the problem of the instantiators and have all the scenes organized, we will program all the mechanism to change scenes. We already have the transition to the lose screen, but as soon as we get there, we want to be able to play again. We create a script called ChangeSceneOnAction and add it to a new node with the same name. This script will wait for the player to press a specific key and, when that happens, change the scene immediately. However, we must avoid the script being active from the beginning. Imagine that we use the fire key to change scenes. When we play, we are enthusiastically pressing the space key. If we lose and change to the lose screen, this script is immediately active and, as we are still pressing the key, we immediately switch back to the game. To avoid this situation, we will also add a wait time so that the player cannot accidentally change scenes. We declare a variable for the action that activates the scene change, another to define which scene we will change to, another for the wait time to be able to change scenes, and finally a float count to count the time. In the process function, we increment the counter and test if the action was triggered and if the time has already passed. If both conditions are true, we execute a command that changes the scene. Since the action name and scene can be changed in the inspector, this script can be used whenever the press fire to continue option needs to be implemented. In Godot, we configure the fire cannon action and the level 1 scene. In the delay, we put 1 second. When we run the scene in F6, we can see that if we press space, the scene changes to the game. And if we lose again, we are sent back to the lose screen. We can copy the ChangeSceneOnAction node and add it to all scenes. In the intro, we jump to the menu, and in the main menu, we jump to level 1. In the win screen, we also jump to level 1, and in credits, we jump to main menu. As we can see, when we win, we still don't go to the win screen, and for that to happen, we count how many aliens are in the scene. If all are removed, and the player is still alive, then we can assume that the level was successfully completed. In the alien script, we add a variable for the game data. In ready, we reference the game data and increment the level alien count. This way we are increasing the count of aliens every time an alien appears in the game, including the boss. Later we will use this count to know if we have killed all the aliens. However, we must ensure that the count decreases whenever an alien is removed from the scene. We use the exit tree method, which is executed when the element is removed from the scene, to decrease the count. Each alien that enters adds one value, and each alien that leaves removes one value. But if we don't destroy the alien, it exits the screen and keeps moving infinitely downwards. Like the lasers, we use the visible on-screen notifier to remove the element if it's no longer visible. Finally, in the level manager, we duplicate the logic that tests the end of the player's life, but change the variable to react to the alien count and to load the win screen scene. When we run the game, we can see that it is now possible to destroy all the aliens and jump to the victory scene. The last form of interaction and scene change missing in this game is using buttons in the menu. We will create a new script inherited from button named ButtonChangeScene. In the main menu scene, we had 3 buttons named Button Play, Button Credits, and Button Quit. The text on the buttons should also indicate their function. After everything is set up, we add the script to the Play and Credits button. In the script, we declare a variable for the name of the scene to load and also declare a new method to load the scene. In Ready, we connect the signal bottom down, which marks the moment the button is pressed, to the ChangeSceneNow method. As you can imagine, this script is generic and can be used on any button used to change scenes. In Godot, we go to the Play Buttons inspector and change the scene name to Level 1, and for Credits to Credits. The Quit button will require a different code. We create a script called ButtonQuitGame, also inherited from button. We can copy the body of ButtonChangeScene script entirely. We just have to ensure that instead of changing scenes, it executes the command to shut down the game. The variable is also unnecessary. To maintain consistency in the code, we also change the name of the method to QuitNow. In Godot, we add the script to the button and run the scene in F6. If we press Quit, the game shuts down as expected. If we press Play, Level 1 starts. If we press Credits, we jump to the credit scene. In the credit scene, we still lack a way to return to the main menu. We can in fact have more than one way. One way could be we copy the play button from the main menu scene and place it at the bottom of the screen. We change the text to main menu and modify the variable. For the second way, we copy the ChangeSceneOnAction from the main menu and change the action to UI cancel. We also need to update the variable referring to the scene. UI cancel is a pre-configured action in Godot. It reacts to the escape key, which means that the escape key will cause the credit scenes to close and return to the main menu. Let's test it. It works perfectly. This ChangeSceneOnAction that uses the escape to return to the main menu can be copied and pasted into the lose and win screen. This way, when the player wins or loses and is presented with the final screen, pressing Fire Cannon repeats the game, but pressing Escape returns to the main menu. We can also add this node to level 1, so we can exit the game mid-game. In the win screen scene, we will add some labels to write the score value, so the player is aware of their performance. We duplicate the first label and change it to your score with a smaller size. We duplicate this last one until we have 4 labels in total. In the second one, we put 0, in the third, we write best score, and in the last, we write 9. To the second label, we add the WriteHighscore script. If we win the game, we can see that in the win screen scene we have your score number. We could create a new script just for this label, but we can also make the previous script more generic. We open the win score and add a string variable named prefix with the value score. In the text, we write prefix plus value. Now in the inspector, we can have different prefixes in each scene. Just write in the variable what we want to appear. So in the case of level 1, we don't change anything, as the score is already written there. But in the win screen, we delete the prefix. For the best score, we need to create a new script called WriteHighscore, inherit from label, and copy all the code from WriteHighscore. We need to change the variable name in GameData, delete the prefix, and the connection to the event system, as we only need to write this number once at the beginning of the scene. In the credits scene, we had the appropriate credits. If you want to use different fonts, make sure you have the copyright for the font and add the files to a folder within the project folder. To use, just select the label and change the font, dragging the font file directly to the variable. To finish, let's add music. In the Sound folder, we select the music and, in the Import tab on the top left, we select the loop option and re-import it. We create a new 2D based scene and save it as music player. This will have only an audio stream player with the music set to autoplay and adjusted to -12 decibels. We save the scene and add it to the autoload. In General, Application, Run, we set the intro scene as the main scene, and when we press play or F5, the game will start in this scene. When we export it, this will be the first scene to open. Our game is finally complete. In this first experience with Godot, we delved into the basics. We explored the structure of scripts and the interaction between nodes and scenes. By building a game from start to finish, we were able to illustrate much more than a conventional tutorial. We revealed the complex interplay between game systems that go beyond basic operations. It's true that during the development of a project, we often turn to small tutorials to refresh our memory on certain aspects of the game engine. However, when making a more ambitious project, we cannot lose sight of the need for all the elements to work in harmony with coherence and efficiency. I hope to have demonstrated a more comprehensive overview of the game development process, although aware that there are numerous details yet to be explored. For example, we could have camera shake during the explosions, add alternate movements for the aliens. The cannons can evolve over time. There can be more than one boss per level. The basic structure is there, but in reality, the game still has a long way to go before it's truly complete. Copy exactly what was demonstrated in this lesson. Make the win screen and lose screen automatically switch to the main menu if the player does not interact for 5 seconds. Apply the same mechanism to make the intro and main menu alternate every 10 seconds. Add an options scene to adjust the volume of the music.